Hello everyone, my name is César Munguía. I'm going to present the work Pineapple Dehydration in the Thermosolar Plant for Agricultural Products installed in Xochitepec, Morelos. I'm a master student at the Renewable Energy Institute of the National Autonomous University of Mexico. In Mexico, 40% of the food is lost. These losses mainly occur in the production, storage, and distribution stages, and end up in the landfill, being another source of CO2 emissions. Also, it's common to observe open sun drying for drying some agricultural products. However, the quality and innocuity of the products are not good enough due to the exposure to different contaminants. Therefore, a hybrid thermosolar LPG plant was developed and installed in Xochitepec, Morelos, Mexico. The plant has a distributed type forced convection hybrid solar drying system with the following components. On the top, the solar air heaters, the flat plate solar water heaters, a weather station, and inside the building, the drying chamber, the thermotank for hot water, and also all the equipment for the food processing. Also, the plant is instrumented and controlled with 52 temperature sensors, 2 water flow meters, 2 air flow meters, 5 relative humidity sensors, and 2 pyrometers. And here you can see a photo of the drying plant. The direct air heating system consists of 16 solar air heaters designed and patented by the Renewable Energy Institute. These are in an arrangement of 2 collectors in series by 8 in parallel, and it works with an axial suction fan of 3 horsepower. The drying chamber has a drying area of 52 square meters. The solar water heating system consists of 16 solar water heaters in an arrangement of 2 collectors in series by 8 in parallel. An thermal isolated storage tank of 2,500 liters and a recirculation pump of 0.5 horsepower. The indirect air heating system consists in the storage tank, an other recirculation pump of 0.5 horsepower, an air-water heat exchanger, and an LGP backup system to heat air with a heat exchanger in case of rainy days or low solar irradiance. The thermosolar plant has different operation modes. In this test, we use only 2 of them, the direct and indirect mode. A typical day of operation is that at the beginning of the day, the drying chamber is preheated with the indirect air heating system. The hot water from the storage tank heats the air that passes through the heat exchanger. After that, the direct air heating system is used during the solar day, while the solar water heating system heats the water that is stored in the thermotank. Because at the end of the solar day we are going to use again the indirect mode, so we can continue the drying process for a few more hours. One test was carried out on June 10th. The figure shows the ambient temperature, relative humidity, and solar irradiance for that day. We dehydrated 155 kilograms of fresh pineapple, and after the dehydration process, we obtained 12 kilograms of dried pineapple with a final moisture content between 6 and 7%. The first figure shows the inlet and outlet solar air heaters field temperatures with an average temperature increase of 15 degrees. The second showed the global instantaneous thermal efficiencies that were between 40 and 60%, and the power of the solar air heaters was between 5 and 20 kilowatts. The direct air heating system had an effective operation time of 6.6 hours. The field of solar air heaters had an average thermal efficiency of 47%, with an average useful power of 30 kilowatts. In this slide, the first figure shows the temperatures of the field of solar water collectors, and we can see how the outlet and thermotank temperature increases through the day. On the second figure, we can see the efficiencies of the water heating system that were between 30 and 50%, and the power of the system was also between 5 and 20 kilowatts. The water heating system had an effective operation time of 6.4 hours. The field of the solar water collectors had an average thermal efficiency of 44%, and the final water temperature in the storage tank were near to 80 Celsius degrees. For the indirect modes, the effective operation time was 2.9 hours in the morning and 2.23 in the afternoon. The heat exchanger had an efficiency of 55% and 63% in the first and second indirect mode respectively, with a useful power of 7 kilowatts in the morning and 13 kilowatts in the afternoon. These figures show the drying chamber inlet and outlet temperature and the thermotank temperature for 12 hours of continuous operation with solar technologies, which mean that it worked with 100% solar fraction. Almost all the day we reached up to 40 Celsius degrees at the inlet of the drying chamber. In this slide, the drying kinetics in dry bases of pineapple in 5 different positions in the drying chamber are presented. As expected, the pineapple slices closer to the hot air inlet dried faster than the other ones. In the first mode, we had an effective operation time of 2.9 hours, in the direct mode 6.6 hours, and at the second indirect mode 2.2 hours, giving a total operation time of 11.8 hours. With all this energy and temperatures, we could be able to remove 72 kilograms of water, giving a drying efficiency of 29%. The cost and return investment analysis is shown in this table. Considering one batch, the energy delivered at the entrance of the tunnel is equivalent to 29 kilograms of LP gas. That result in $35 savings. Considering that we can make 280 batches per year, we could save 20 tons of CO2 annually. Having an estimation of the investment cost of both technologies of $35,400, the payback period could be 2.8 years, and with the Mexican government incentive of 2 years. In this slide, you can see some pictures about the process, also the drying chamber with all the product inside, and also the presentation of the final product that in the past months it has been commercialized. For the conclusions, the thermal efficiency obtained in the solar water collectors was 44%, and for the solar air heaters, 47%. The power capacity of the solar air heaters was 13.77 kilowatts and 13.13 kilowatts for the solar water collectors. 155 kilograms of fresh pineapple were processed, resulting in a total of 91 kilograms of pulp with 87% of initial moisture content, and at the end of the drying process of 11 hours, 12 kilograms of dry pineapple with 6% of moisture content were obtained. The global drying efficiency, considering the direct mode and the indirect mode, was 29%. With all this, a hybrid thermosolar LPG plant was designed, built, and evaluated in Xochitepec, Morelos, for the dehydration of different agricultural products. According to the results obtained, different kinds of products can be dried on this plant, resulting in substantial fuel saving and environmental benefits. This plant was developed as a result of the project Development of Low and Medium Temperature Solar Collectors for Process Heat in Industry, awarded by the 2017 Prodetes Award. We also want to thank you to Solar for It and to IDI Solar Company, and to the students Alejandra, Montserrat, Jessica, Paola, and Emiliano and Roberto for their help. Thank you.